So in this video we are discussing about the chemical addition or the injection method, and we are going to compare the two common methods. So in fact the glycol and methanol, these are the two common basically chemical that are being added into the natural gas for the prevention of hydrate formation. So we are going to discuss about we are going to compare these two methods with respect to temperature, with respect to the injection techniques, with respect to the potential downstream problems, with respect to the economics, and with respect to the existing hydrates. So the first one, comparison of these methanol and glycol with respect to the temperature. So in this one, methanol can use at any temperature. So we can say it has a advantages here. Dry ethylene glycol usually not chosen below 15 degree Fahrenheit. So we can say this is one of the problem, and due to a reason because of high viscosity. And the second is a difficulty for separation from the hydrocarbons because the miscibility will be very high. So above 20 degree Fahrenheit, ethylene glycol preferred over ethylene glycol due to lower vaporization losses. So within the glycols, we can go for the ethylene glycol. So you can say for ethylene glycol rather than we can go diethylene glycol rather than ethylene glycol. But ethylene glycol shows more depression of hydrates than diethylene glycol on per pound basis. So on this basis, ethylene glycol is good as compared to the diethylene glycol. So methanol is superior to both ethylene glycol and diethylene glycol on per pound basis. So we can say that methanol is the best one as far as the per pound hydrate depression is concerned. Then ethylene glycol, the second one, and after that this is the first one, this is the second one, and after that diethylene glycol, the third one. So if you compare all these things, so methanol can be a better option as far as the temperature is concerned, because it can be operated at any temperature and it have a very good basically the depression of hydrate per pound basis. Now come to the injection techniques method. So injection technique is how to inject these chemicals in the flow line, or you can say in the system, in the natural gas. So that is the injection techniques. So glycol must be sprayed into the wet gas as a very small droplets. So we need for the glycol, we have the spray system, very good spray system, so that proper mixing with the natural gas can be possible. If mixing of natural gas and glycol is not achieved, glycol injection may not prevent the hydrate formation. So overall, we can say that glycol mixing is very important. For that thing, we need the spraying system for the glycol. Now comes the methanol. So as far as the methanol is concerned, the injection technique is not very much critical between the methanol, because the methanol evaporated into the gas stream. So normally the methanol has 64 degree Celsius the temperature. So we can say that methanol is very easily evaporated in the gas stream, and it is mixed with the gas stream because it is now in the gas phase. So it is much better as compared to the glycol as far as the injection techniques are concerned. So in the injection techniques, methanol is first one and glycol is second one. Earlier temperature, methanol is first one. Now come to the glycol aspects. The diluted glycols are separated from the gas, reconcentrated and reused. So this is one of the benefit, that you have to recycle the glycol again and again. So it means there are no loss of the glycol when you are using the glycol in the natural gas, because you are recovering the glycol, you are separating the glycol from the natural gas. But the methanol recovery may be marginally economical due to its low cost and high vaporization losses. That is a problem, because since it is vaporizes in the natural gas, so it is very difficult to recover all these methanol from the natural gas. So economically there are more losses with the methanol as compared to the glycols. So glycol is usually cheaper where continuous injection is required and high gas volume are being inhibited. So for that thing, because obviously if the gas volume is very high, means high amount is required. So glycol is cheaper because you can take continuously, recovery of the glycol is possible continuously, so there are very small losses. And if you go for the methanol, the high volume treatment required a high amount of the methanol. So it means that you are going for the losses with respect to the methanol. So here the glycol is a very good option for the higher volumes. Because of the lower capital investment, methanol is frequently used for the low gas volumes, temporary installment, and where the hydrate problems are mild, infrequent and seasonal. In these cases you can go for the methanol basis. So where the gas volume are low, we can go for the temporary installation. Means sometimes we need that one, sometimes we don't need, where the hydrate problems are mild and infrequent and seasonal. For that thing we can go for the injection technique. So now the next point are downstream problems. On the basis of downstream problems, so methanol can can cause the three problems if the gas is passed through a glycol dehydration plant. Downstream problem means that if you are using these chemical injection techniques at the very starting level of the natural gas, and ultimately we need to remove permanently in the dehydration plant. So downstream problem means when these natural gas are being treated into the dehydration plant, it is being treated for the permanent solution. So what will be the problem arises because of these conditions? So in this scenario, methanol is co-absorbed with water vapor by the glycol and increases the glycol regenerator heat load. So what happens if the methanol is present? So this is the problem with the methanol. So aqueous methanol can corrode the carbon steel and glycol steel and reboiler vapor space. These means that these two are the main problem when the methanol is injected in the natural gas, and when these methanol are not required at that earlier stages, these methanol are basically available with the natural gas, and when we are going for the dehydration plants, so this methanol can corrode the carbon steel in the glycol steel and reboiler, number one. Number two, it also increases the glycol regenerator heat load because it will be co-absorbed with the water in the methanol dehydration plant. That is the two problems with the methanol. Methanol can also reduce the capacity of the solid desiccant pellets because the methanol is readily co-absorbed into the gas dehydration plant. So that is also a problem with the methanol. So we can say methanol can create a lot of problem in the downstream, whereas the glycol cannot create the problem because of the regeneration, as well as glycol is a part of the dehydration. Next, if a small amount of the hydrates are already present, then what will happen? While the glycol can prevent the hydrates, it will not attack or dissolve the hydrates that are already present in that one. Means it can only prevent but not dissolve the already present one. On the other hand, the methanol can dissolve the existing hydrates to some degree. So we can say in this one, methanol have an upper hand as compared to the glycol. So normally glycol units are required when the methanol injection rate exceeds 30 gallons per hour. So that is basically one of the case when the amount of methanol is increasing because there are continuous loss in the methanol. So the 30 gallons per hour, more than 30 gallons per hour of the methanol is required for any case in the natural gas prevention of dehydration. Then we can go for the glycol units. So the economics, as far as the economics is concerned, so the methanol injection has low investment cost, but the high operating cost due to chemical consumption, means there are no recycling option. Ethylene glycol and diethylene injection has a high investment cost but low operating cost because of the recycling options. And the line heaters are characterized by the intermediate investment cost between the methanol and ethylene glycol. The operating cost depends upon the value of the fuel consumed. So we can say methanol have a good one, but they have a high cost in the operating system. Means due to the operating cost. Glycol have a low operating cost, and line heater have between these two. So this is all about the comparison between these two. Thank you.